Fine. So this is the formula. Now look at the question. Two identical circular loops, P and Q. You have two loops, P and Q, each of radius R. Is the value of A in this formula now turns out to be R and carrying a current of I and 2I amperes respectively are lying in parallel planes, which means both loop P and Q, their planes are parallel to each other and that they have the plane perpendicular to the uh, your monitor. So if you consider your computer monitor as a plane, then the planes of the coil P and Q are parallel to each other and then they are perpendicular to the plane of your monitor or your notebook. So and they have a common axis. The distance between as the diagram, the distance between the center of both the loops is R. Now, the direction of the current in both the loops is clockwise as seen from the point O, which is at equal distance from both the centers. So, when you stand at point O and when you're watching the current which is flowing in P, the current is flowing in the clockwise direction in coil P, and when you stand at point O and observe the current which is flowing in coil in the loop Q, here also the current is flowing clockwise. So in the first case, the current is I. In the second case, the current is I. Now you have to use your right hand thumb rule. Suppose if I'm standing at point O and looking at the coil, the loop P, for me the current from here the current flows clockwise. So the direction of the magnetic field will be was you have to hold uh, your fingers of your right hand. The fingers of your right hand should curl in the direction of the current. Current is facing the current is the point O and watching the coil P. There the current is created by the loop at point O will be BP. Uh, the only thing is that you have to read later on. Think that in the loop, the direction of the magnetic field is given by your thumb. The fingers will be wrapped in the direction of the current. Same way, the direction of the magnetic field created by the loop Q will be pointing in this way. So it is only the point of observation that matters. Just use your right hand thumb rule and find the direction of BP and BQ. This is how it happens to be. Now, BQ will be of greater magnitude than BP. The reason is both the loops are situated at equal distance from point O, but the coil Q carries twice the current as that compared to that of coil B. Coil P. So BQ will be of greater magnitude than BP. So the net field B becomes equal to BQ minus BP. Copy the diagram, boys. Copy down the diagram. Mark the direction of the magnetic field, and later on you just use your right hand thumb rule, where your fingers will curl along the direction of the current, and the thumb will point along the direction of the magnetic field. That roughly draw the diagram, and then we'll go for writing an expression for BQ and BP. BQ and BP are the magnitudes of the magnetic field. Let's have a rough diagram first. It's only half an hour, and I have to leave you. So let me go for the next slide. Okay. Shall I go for the next slide?
Yes, ma'am.
So let me one second. Let me draw. Let me once again write the formula, and then we'll go for applying for BP and BQ. The general formula is B is equal to B will be equal to mu naught I a square divided by a squared plus r square, the whole power of 3 by 2. So the radius of the loop A is equal to given as R. So now I'll go for BQ. BQ will be equal to mu naught current flowing through it is 2I. A becomes R square 2 into R squared plus R squared, the whole power of 3 by 2. So now this becomes mu naught into 2I divided by R square by 2 into what will be that, boys? R squared plus R squared is 2R squared, the whole power 3 by 2. So it is to the power of 3 by 2 into R squared plus R squared into 3 by 2 will give you R cube, right? So this is to the power of 1. What will be the answer here? So this and this will get cancelled. Mu naught, shall we cancel these both? So it will be mu naught I by 4 root 2 R. Is that correct? Because 2 to the power of 3 is 8. Square root of 8 is 2. Square root of 8 is 4. Is that correct?
It will become 4 right?
Yes. 4 root 2 into R. That is BQ. Then what is BP? The same. Only thing is that you will have mu naught I R squared by 2 into 2 to the power of 3 by R cube. So that will be, what is BP? Sorry, boys, here did I make a mistake? Cube root of 8. Cube root of 8 is 2 root 2.
Yes, ma'am.
This is 2 root 2, right? Okay, what will be BQ? Sorry, BP. This is BQ. What will be, I think so, it will be mu naught I divided by 4 root 2 R into R. So now you know the value of Q, you know the value of BP, then you need to subtract both. Just get the value, boys. I just want you to make familiarize with BQ and BP. What is the final answer? Can you all do this, boys? So BQ minus BP. What will be the final value? So it will be 2 minus 1. I think so. Mu naught I divided by 4 into root 2R. Is that correct, boys? What will be the
Yes.
value of B? Will you be able to calculate the value of B? B, the net magnetic field at point O will be BQ minus BP. Anyway, that do it as a homework. So I'll go for the next numerical. Fine. Look at this, boys. An electron moving horizontally with a velocity of 4 into 10 to the power of 4 meter per second enters the region of uniform magnetic field. So V is equal to 4 into 10 to the power of 4 meters per second. Magnetic field B is 10 to the power of minus 5 Tesla vertically upwards. I'll give you the diagram. So it's moving with velocity of v, vertically upwards in that sense. This is the diagram. The magnetic field is into the plane of the gauge. So the moment the particle enters a magnetic field, right, it experiences a force and moves upward. The radius is given as the radius of the particle. The diagram being given. So velocity v, draw its trajectory. Trajectory is this, the one which I've highlighted in black. Else, let me highlight. First, this will be the trajectory. So it will, you know how to find, boys, your forefinger of your left hand. The forefinger of your left hand should point into the plane of your computer monitor. You're sitting in front of your computer monitor. Your magnetic field is into the plane of your monitor. Cross field means what? All your field lines are into the plane of your monitor. So what you need to do is the forefinger of your left hand, stretch it away from you. The forefinger should point away from you, which means the forefinger will point into the plane of the monitor. Then it is an electron, boys. It's an electron moving horizontally. So your current will be in the direction. Your current will be in the direction opposite to the direction of the electron. So your current will be. So in that case, in which direction will it move? If the current is moving, it's entering the field. What will be the trajectory, boys, in that case? Cross field, will the trajectory be in the upward direction? Because sometimes the question also goes wrong. Your forefinger should be pointing in the direction of the magnetic field. Your center finger should uh, point in the direction of the current. Keep this in mind. The center finger should point in the direction of the current. Current is always in a direction along the direction of the motion of the positively charged particle, or the current will always point in a direction opposite to the direction of the motion of your electron. If that is the case, will the electron move upward or will the electron move downwards? Because all these things are very important in magnetism. One
Um,
second. Yes. So your
ma'am,
field is crossed. Your field is crossed. Your field is crossed means your forefinger should be pointing into the plane of your computer monitor, which means your forefinger should point away from you. So your electron is entering the field. So the direction of the motion of the electron will be opposite to the direction of the forefinger into the plane. So the direction of wind, the direction of
Ma'am,
your,
we can't hear you, ma'am.
okay, sorry, because I'm just blocking when I'm writing. Okay, your center finger.
Very inaudible.
Now it's audible.
Yes,
Yes,
ma'am.
ma'am.
Okay, I think when I'm writing, I'm blocking
Yes,
the
ma'am.
other. Okay, the center finger will be in the direction of the current. Current is always opposite to the direction of the flow of your electrons, which means forefinger into it. Current, your center finger will be pointing towards your left. I'm talking about your left hand. Forefinger into the plane of the monitor. Your center fingers should be stretched right towards your left. Then in which direction is your thumb pointing? Let me say, check. In which direction is your thumb pointing? Is the thumb pointing, boys, forefinger into
down.
the plane of the monitor? Your center finger should be pointing towards your left because current flows in a direction opposite to
Yes,
that of
ma'am.
your electron. So your thumb will be pointing downwards, which means that
Yes,
Yes, ma'am. Downwards.
down. A trajectory is completed. Now look at the second part of the question. Find out the time it takes to come out of the region of the magnetic field. See, when the particle undergoes a circular motion, is it complete circular motion when it is coming out of the field? Is it a circular motion or is it a semicircular motion? Boys, when it is
Semicircular.
semicircular motion. So then in that case, your time period, what is the time period for the circular motion? T is equal to, for circular motion, a complete circular path. For the complete circular path, the time taken is called the time period. It is 2 pi R divided by V?
V,
Yes or
ma'am.
no? Okay, now
Yes.
this is a semicircular path. When it comes out of the charge particle, comes out of your field, it's a semicircular path. For semicircular path, what will be the value of the time taken? T half, right? T
Ma'am, pi
becomes
r
equal to,
by V, right?
yes, it will be pi r. Pi r divided by V. Now the
Ma'am,
question is,
in the question it says the magnetic field is acting vertically upward.
the magnetic field is, okay,
Ma'am, like
might
it
be that,
says
yeah, correct.
acting
Magnetic
vertically.
field is vertically upward. Diagram shows, the diagram in the picture shows it is vertically inwards. Right, boys? The diagram is showing vertically inwards. There is a right.
Okay, ma'am.
So according to the diagram, it's a cross field. Now look at this, boys. Is it possible for me to find uh, the time taken for the charged particle to come out of the magnetic field? Look at the formula. T is equal to pi r divided by v. V is given. Velocity is given. The radius I have to find. Now, how will I find the radius? Let me know. How will I find the radius?
MV by BQ, right?
Yeah. So, one second. What is when a particle moves in a magnetic field? It is
Your voice is breaking a lot.
yeah. Once because when I'm writing, I think so. I'm obstructing the microphone. I have to use my left hand. Otherwise, let me go for one second. The other device I let me use. So now, what is the formula? mv squared by r. mv squared by r qv because uh, sine theta becomes equal to sine 90 degrees. Now, can you give me an expression for r? What is r? Is it mv divided?
Ma'am, you're still inaudible.
Now, am I audible? R is equal to was centric when
No,
a
now.
charge okay when a charged particle enters a magnetic field, the centripetal force mv squared by r is equal to is provided by the magnetic force. Because when a charged particle enters a magnetic field, it undergoes a circular path. When the angle between velocity vector and magnetic field vector is 90 degrees. So the centripetal force is provided by the magnetic force. What is the formula for centripetal force? mv squared by r. Magnetic force is bqv sine theta. Here theta is 90 degrees because the angle between the velocity direction of the motion of the electron and the magnetic field is 90. So can you get me an expression for R? R is equal to mv divided by bq. Can you substitute this in the formula, the time taken for the semicircular path? Now, what is the mass of an electron? Boys, what is the mass of an electron? 9.1 10 to the power of minus 31 kilogram because
Yes,
this is
sir.
an electron. Okay, so m is equal to 9.1 into 10 to the power of minus 31 kilograms. Then velocity is given. You have the strength of the magnetic field given. The charge q of an electron is 1.6 10 to the power of minus 19 coulomb. Can you substitute and find this, boys? Find the value of find the value. Let me check. What is the value? Boys, can you do this?
Yes, ma'am.
Yes. Yes, ma'am.
What is the value of R?
Ma'am, T into V by 2I, 2 pi.
It is 2 into are you getting 1.97 into the power of minus 7 seconds? Boys, answer is the time period is sorry, the time will be 1.97 in
Ma'am, could you repeat the power? Your voice cut off.
10 to the power of minus 7. Approximately 2 into 10
Yes.
to the power of minus 7. Okay. So anyway, write the formula. Now I'll go for the numerical. A straight wire of mass 200 grams and at a height 1.5 meters carries a current of 2 ampere. It is suspended in mid-air by a uniform magnetic field B. What is the strength of the magnetic field? So let me draw the magnetic field. Let me take the magnetic field or cross field. I think so I'll be obstructing my microphone. Fine. So this is your magnetic field. It's a uniform magnetic field. There is a wire, right? A wire which is at a height of 1.5 meter carry a current of 2 amperes. Now the mass is 200 grams. So the weight is m into g. It is suspended in mid-air by a uniform magnetic field. See, a current carrying conductor placed in a magnetic field, right, will experience a force. Now, if this conductor has to get suspended in air, the force it experiences, which is equal to BIL sine theta. The current carrying conductor placed in a magnetic field will experience a force F is equal to BIL sine theta. Now, if these two forces, one is the weight of the wire acting in the downward direction and the force it experiences due to the magnetic field, which will be acting in the upward direction. Is it upward? Your Fleming's left hand rule? Was your Fleming's left hand rule. Stretch your forefinger. Look at the field. The field is a cross field, which means the field is pointing. Your forefinger should be away from you. It should point towards your monitor, right? The wire is lying, think the wire which is carrying the current is lying on the plane of your monitor, right, boys? Your forefinger of your left hand should be stretched away from you, which means it should point towards the monitor. Then stretch the center finger. Right? You have to stretch the center finger along the direction of the current. Then naturally, your thumb will be pointing upwards, forefinger into the plane of the computer monitor. Then your center finger along the direction of the current, that is along the direction of the plane of your monitor, then naturally your thumb will be stretching upwards, which means the force is acting in the upward direction. So if the wire has to get suspended in mid-air, F will be equal to m into g. The theta will be 90 degrees. This is the angle between the direction of the current and the direction of the magnetic field. The, the coil, the conductor which is carrying current that is lying on the plane of your monitor. D by M must be equal to M. So find value. Take G as 10 meter per second square. Mass you have to convert 200 into 10 to the power of minus 3 kilogram. First time the length is given. One second. Is that or it's
Is it 0.65?
length as well. So length and height. Length 1.5 meter. What is the answer? 0.
Ma'am, is it 0.65?
0.65 Tesla. Correct, was 0.65 Tesla. So the length is 1.5 meter. Take acceleration due to gravity as 10. Mass is 200 into the power of minus 3 kilograms. Current is 2 amperes. So your answer should be approximately 0.67 Tesla. Just check.
Yes, ma'am.
It's fine. Okay, one more numeric I'll finish it off, boys. Shall I move on? Later on, you check your values, you know how things have to be worked on.
Yes, ma'am.
Okay, I'm moving for the last numerical. A beam of proton passes undeflected with a horizontal velocity to a region of electric and magnetic field. Now tell me, these two fields are perpendicular to each other, and the fields are normal to the direction of the beam. See, when a particle enters an electric field and then a magnetic field, in both the cases it experiences a force. Now, what is the electric force? The electric force experienced by the charged particle due to the electric field is Q into E. So this is your electric force, the force due to the electric field. And what about the force due to the magnetic field? The force due to the magnetic field is Fm, that is equal to QVB sine theta. Here they are stating that the particle is entering in a direction perpendicular to the direction of both electric and magnetic field. Theta becomes equal to 90 degrees. So Fm is equal to QVB. Now it is moving in both the fields. Now look at the condition. It goes undeflected. What do you mean by that? Both the forces should be equal in magnitude but opposite in direction. Are you clear, boys? Are you clear?
Yes, ma'am. I clear.
Okay. So FQ must be, sorry, FE must be equal to F. Can you find the value? The question is, find the velocity of the beam. See, the charge of an electron Q is 1 point anyway. Q and Q will get cancelled. Q E is equal to Q B B. So what is B? B is equal to B by B, right? So this is an expression for V. Sometimes they'll ask you to derive an expression for V. So this the V is equal to E upon B. The value of E is given as 50 kilovolt per meter. So 50,000 volt per meter. And B is given as 100 millitesla. 100 into 10 to the power of minus 3. So E becomes equal to 50 into 10 to the power of 3. B is 100 into 10 to the power of minus 3. So what is the velocity? What will be the value of V? What is the value
Ma'am, just a minute.
of? Okay.
Is it 5 into 10 raised to 5?
Yeah, 5 into the power of 5 meters per second. Are you all getting boys? V is 5 into,
Yes, ma'am.
and I'm writing, sorry, boys. The value of V is 5 into 10 to the power of 5 meters per second. Now look at the second question. I'll finish this part. The question is, okay, the particle is entering both electric and magnetic field, right? Now, what is the velocity with which it is going to come out? This is the velocity. Now, force with which when it comes out of this magnetic and electric field, it is forced to strike a target on the screen, right? Force with which it strikes a target on the screen, uh, if the proton beam current is equal to 0.80 milliampere. So force, Newton's second law of motion is force into moment by time. What is force? Rate of change of moment. So delta P by delta T. So what is your moment? MV, right? Now I have to go for your time. Now see, the question is dealing with current. So I have to go for I is equal to Q by T. So what is T then? Q by I. Q is the charge of the proton. What is the charge of a proton? Was, are you clear what I am stating? Momentum is m into v. Time is Q by I. Q into I. Okay, what is a charge of a proton? What is the charge of a proton, boys?
1.6
1.6 10 to the power of, okay. And anyway, they want the expression because the problem is, okay, velocity is given, charge is 1.6. Unless and until they give you the mass of the proton, you can use the value of the mass of the proton, but the charge of a proton is 1.6 10 to the power of minus 19 coulombs. Anyway, boys, uh, I've completed this. I told you to be till half an hour, so it's fine. You can leave tomorrow. Same time, I'll take half an hour.
Yes, ma'am.
Is that fine? Thank you, boys. You can leave.
Thank you, ma'am.
Thank you.